Hello and welcome back everyone. Today we're going to review the entire chapter of physical quantities and measurements. So let's get started. So first, what exactly are physical quantities? A physical quantity is a quantity that can be measured, such as length, mass, time, temperature, etc. And all physical quantities always will have a magnitude and a unit. Now let's see an example. Let's think the length of an object is 10 centimeter. Here, length is the physical quantity, 10 is the magnitude, and centimeter is the unit. Now there are two types of units, the base unit and the unit with a prefix. For example, the base unit of length is meter, but we can also use centimeter, kilometer, nanometer, etc. Centi, kilo, nano, these are all called prefixes. And how do we convert a prefix into a base unit and vice versa? So to do that, you will need to memorize this chart for unit conversions. So this chart is extremely important for unit conversions. And once you properly understand this chart, you can convert any prefix into a base unit and base unit into prefixes. So to convert a prefix into a base, what you're going to do is multiply by these numbers. And to convert a base unit into a prefix, we're going to divide it by these numbers. Now let's see an example. Let's say we want to convert 5 centimeter into meters. So 5, and since it's converting from prefix to base unit, we will be multiplying it. So multiplied by 10 to the power minus 2. And that is the unit in meters. And to do from meter into centimeter, we're just going to divide it by 10 to the power minus 2. And therefore we will again get 5. Now let's move on to some common physical quantities and how we can measure them. So first we will check out length. Length is the distance between any two points. And we can measure it using different instruments for different ranges. For example, for a range that is greater than 100 centimeter, we will always be using a measuring tape. And the precision of this measuring tape is 0.1 centimeter. And for ranges within 0 to 100 centimeter, we can use a meter rule or a ruler. And the precision is again 0.1 centimeter. Now for smaller objects such as 0 to 10 centimeter, it is often better to use a vernier calipers, and that's because the precision is higher at 0.01 centimeter. Now for very small objects around 2.5 centimeter, always use a micrometer screw gauge because this will give you the greatest precision of 0.001 centimeter. Now let's see how we can read a micrometer screw gauge. So in a micrometer screw gauge, this is called the main scale and this is called the circular scale. First you will write the value from the main scale. From the main scale we can see that the value here is 1, 2, 3, 4, 5, 6, 7. So first 7, and then we have a 0.5 over here on this side. So that is 7.5 in the main scale. And then you will add the value from the circular scale. So plus, can you see that this line is perfectly aligning with the main scale? This is the value you have to take. So this is 10, 11, 12, 13, 14. So plus 0.14, and that will give you 7.64 millimeter. And this is the reading for this micrometer screw gauge. Now let's check the value of the other micrometer screw gauge. Here the reading is 1, 2, 3, 4, 5, 6, and there's another 0.5 over here, so that is 6.5, plus the circular scale reading that is around here, so 10, 11, 12, 13, 0.13. So the total reading is 6.63 millimeter. Yeah. So that's how you can read a micrometer screw gauge. Okay, now moving on to volume. So the volume is the amount of space occupied by an object. And you can calculate volume using two ways. And you can find out the volume using two ways. The first is you can use a formula, but that only works for regular solids, like a cube, a cylinder, etc. Or number two, you can use a cylinder. You can use a measuring cylinder to measure the volume. And for a liquid, when you put a liquid inside a measuring cylinder, take the reading of the meniscus, that is this line over here. That is the volume of the liquid. And if you want to find the volume of an irregular solid, what you're going to do is, first you will take the reading of a liquid inside the measuring cylinder, and you will label that V1. Next you will add the solid inside the measuring cylinder, and then you will check the new reading. And this new reading is V2. And the volume of the solid is equal to V2 minus V1. That is because the amount of space occupied by the solid is V2 minus V1. Okay, now moving on to time. Time can be measured using a clock, a stopwatch, and even a pendulum. So let's see how we can use a pendulum to measure time. So when a pendulum bob moves from one end to another end and then comes back again to its original position, its movement is called one oscillation. And the amount of time taken for one oscillation is called the period. So the period of pendulum is the time taken to complete one oscillation of the pendulum bob. And we can measure this period using a stopwatch. How? Just measure the time taken for 20 or more oscillations, and then to find the period, just divide the total time divided by 20, or the number of oscillations you're taking. And you will repeat this value 3 times or more to calculate the average period. So the more times you repeat it, the more accurate value you will get. Let's see some possible errors and how we can avoid them during measurements. The first one is the zero error, and this occurs when the reading does not start from zero. Let's look at this micrometer screw gauge over here. It says there is no object being measured, but yet there is still a reading on the circular scale, and this is called a zero error. So the zero error is mostly due to faulty equipment. And to avoid zero errors, we can calibrate our equipment properly. Or we can also subtract the zero error from the final measurement. And now comes the parallax error. And the parallax error is always due to the wrong eye position. For example, when you're looking at a scale and you have to take a reading from here, your eye must always be kept perpendicular to the reading you're taking. For example, let's think of this as a measuring cylinder, and this is the level we are taking. So our eye must be kept perpendicular to the level to take a proper reading, or else we might get an inaccurate reading. Okay, now let's move on to the two types of physical quantities, scalars and vectors. So the scalar quantity is something that only has a magnitude. And the vector quantity also has a magnitude and a direction. For example, let's look at some scalars and vector quantities. So speed, distance, mass, time, energy and temperature are all scalar quantities. Because they have no direction, they only have a magnitude. While vector quantities can include velocity, displacement, weight, acceleration, momentum, gravitational field strength and electric field strength. That is because all of these vector quantities have both a magnitude and a direction. For example, for acceleration, we can say that the acceleration is 5 meter per second square forward or backward. So therefore, there is a direction associated with acceleration. Therefore, it will be a vector. Now, it's very important that you remember the scalar quantities and the vector quantities, especially the ones listed over here. Now let's see how we can represent vectors. So vectors are usually represented by an arrow, and the arrowhead shows the direction of the vector. So this arrow is pointing forward, so the vector is forward direction. And the magnitude of the vector is represented by the length of the arrow. So let's assume this arrow's magnitude is 10. So an arrow that is half of it will be 5, and so on. Okay, now how do we add vectors? If the vectors are in the same line, it's very easy to add them. Just assign one side to be positive and the other side to be negative. So let's assign the forward direction to be positive, and the negative direction and the backward direction is negative. So adding them will be 5 plus 1 minus 2 minus 10, and we will get minus 6. So the resultant vector is moving in the backward direction and the magnitude is 6 in this diagram. Now what if the vectors are acting at an angle? When that happens, we will first draw a vector arrow like this, and then we will connect the tip of the arrow with the tail of the other vector like this. And the resultant vector is the arrow that will connect the tail of the first vector to the last vector like this, and it will point from the tail to the tip, something like this. So this is the resultant vector of these two vectors. Now what if the vectors are acting at perpendicular angle to each other? We will again connect the tip to the tail of the vector like this. First draw one vector, then connect the tail of it to another vector. And then connect the tip to the tail like this. And the direction of the vector is the angle over here. This is the resultant vector and its angle is this one. And to get the magnitude of the resultant vector, if the vectors are perpendicular, we can just use Pythagoras' theorem. So A, B and C. So from Pythagoras' theorem we know that A square plus B square is equal to C square. Therefore we can get the resultant vector magnitude very easily. And to get the angle, we can use the tan ratio. So tan theta, let's assume this is theta. So tan theta is equal to opposite divided by the adjacent. So therefore theta is equal to inverse of the opposite divided by the adjacent. So the opposite to the theta is B and the adjacent is A. And using this equation we can get the resultant angle of the vector. And that is the entire summary of the chapter. Hope you liked it and stay tuned for chapter 2.